Friends, welcome to my YouTube channel. Dhanesh here. Today I am going to discuss one of the most important supervised machine learning algorithm, that's a random forest. As I told, a random forest is a supervised learning algorithm. It can be used both for classification and regression problems. But however, it's mainly used for classification problems. A forest is comprised of trees. It is said that the more trees it has, the more robust a forest is. Random forest creates decision trees on randomly selected data samples, gets prediction from each tree, and selects the best solution by means of voting. So that's what a random forest do. Let's get deeper into the random forest. See, before getting into a random forest, in depth, I am going to give some idea on decision tree. See, a decision tree, you may be familiar, is a flowchart like structure in which each internal node represents a test on an attribute. Example, whether a coin flip comes up heads or tails. Each branch represents the outcome of the test, and each leaf node represents a class label. That means the decision taken after computing all attributes. That's a decision tree. Now we will get into the random forest in depth. When we compare a random forest versus a decision tree, say what's the difference between random forest and a decision tree? This is the pictorial representation of a random forest. Here I am comparing a simple decision tree with a random forest. Random forest is a set of multiple decision trees. Deep decision trees may suffer from overfitting, but random forest prevents overfitting by creating trees on random subsets. Decision trees are computationally faster. Random forest is difficult to interpret, while a decision tree is easily interpretable and can be converted to rules. Next, we will discuss about some of the applications of random forest. A random forest has a variety of applications such as recommendation engines, image classification, and feature selection. It can be used to classify loyal loan applicants, identify fraudulent activity, and predict diseases. It lies at the base of Baruta algorithm, which selects important features in a dataset. Now let me give a more clarity on random forest example, a practical example I can tell you, like what decision we will make based on that. See, let's understand the algorithm in a layman's terms. Suppose you want to go on a trip and you would like to travel to a place which you will enjoy. So what do you do to find a place that you will like? You can search online, read reviews on travel blogs and portals, or you can also ask your friends. Let's suppose you have decided to ask your friends and talked with them about their past travel experience to various places. You will get some recommendations from every friend. Now you have to make a list of those recommendation places. Then you ask them to vote or select one best place for the trip from the list of recommended places you made. The place with the highest number of votes will be your final choice for the trip. this is the way you plan. See, in the above decision process, there are two parts. First, taking your friends about their individual travel experience and getting one recommendation out of multiple places they have visited. This part is like using a decision tree algorithm. Here each friend makes a selection of the places he or she has visited so far. The second part, after collecting all the recommendations, is the voting procedure for selecting the best place in the list of recommendations. The whole process of getting recommendations from friends and voting on them to find the best place is known as the random forest algorithm. Next, I want to, tell you like random forest is a powerful ensemble learning algorithm. So you may be familiar with ensemble methods in statistics and machine learning. Ensemble methods use multiple learning algorithm to obtain better predictive performance that could be obtained from any of the constituent learning algorithms alone. Random forest is a powerful ensemble learning algorithm. You need to understand. Next, how this random forest algorithm works. As discussed, it works in 4 steps. Select random samples from a given data set. Construct a decision tree for each sample and get a prediction result from each decision tree. Perform a vote for each predicted result. Select the prediction result with the most votes as the final prediction. Next, I want to tell you about the advantages of random forest. See, it overcomes the problem of overfitting by averaging or combining the results of different decision trees. This algorithm can be used in both classification and regression problems. Random forests work well for a large range of data items than a single decision tree does. Random forest has less variance than single decision tree. Random forests are very flexible and possess very high accuracy. Scaling of data does not require in random forest algorithm. It maintains good accuracy even after providing data without scaling. Random forest algorithms maintains good accuracy even a large proportion of data is missing. Now let me get into the disadvantages of random forest. Complexity is the main disadvantage of random forest algorithm. Construction of random forests are much harder and time consuming than decision trees. More computational resources are required to implement random forest algorithms. It is less intuitive in case which we have a large collection of it is less intuitive in case when we have a large collection of decision trees. The prediction process using random forest is very time consuming in comparison with other algorithms. See, next we are going to discuss about how to build a classifier, random forest classifier using scikit learn. Let us get into the implementation part. See, building the classifier using scikit learn. We will be building a model on the iris flower dataset, which is a very famous classification set. It comprises the sepal length, sepal width, petal length, petal width, and type of flowers. There are 3 species or classes: Setosa, versicolor, and Virginia. You will build a model to classify the type of flower. The dataset is available in the scikit learn library, or you can download it from the UCI machine learning repository. Fine, let's build that model. For that, I will use the Google Colab You may be familiar with Google Colab. See how you can get is you need to just type Google Colab here. You can go to the URL google.research.google.com, Google Colab. New notebook. You have this thing, new notebook, and here you need to change the GPU, that is the runtime. You need to change runtime type to, I am changing to GPU, then save it, then connect it. That's all. You can use Jupyter Notebook as well. It should be fine. I have the code with me. I will run that code to save time. See, first we are importing the scikit library, and the data set also we are loading. That's what we are doing it here. Fine. You can run by clicking the play button. Fine, it's done. Now what we will do is, next is we are printing the target and feature names to make sure you have the right data set. Print the label species. I already mentioned, like Setosa, versicolor, or Virginia. Those things I am trying to print it now. So just printing the values here. Just you can see it. Let me try it here. See, you can see Setosa, versicolor, and Virginia. It's coming now. I am printing the name of the names of the 4 features we are going to get. That's what I am going to do now. Yes, you can see the features. You can see sepal length, sepal width, petal length, and petal width. Petal width you can see here. Now what I am going to do is, see, as you know, it's a good idea to always explore your data a bit, so you know what you are working with. So for that I am just printing some of the you can see the iris data types top 5 records I have, and after that I have printed the labels, iris labels as well. That's done. Now I am creating a data frame of given iris data set. That's what I am going to do next using pandas. I am importing pandas here. See, we can see here. So it's showing the sepal length, sepal width. The data frame is created here. You can see here. Now what I'm going to do is we are trying to separate the columns into dependent and independent variables. That means features and labels. Then you split those variables into a training and test data set. For that we can import this train underscore split underscore split function, and we can do that. That's what I am doing it here. Fine, let me run the code. So it's done. Now here we are splitting the data set into training set and test set. That's what after that we are going to do. Most probably 70% we will take training and 30% we will take testing, right? So that's what I am doing it now. It's done. After splitting, you will train the model on the training set and perform predictions on the test set. You know that. For that, we are importing the random forest model from the scikit. learn, and we are creating the classifier. The Gaussian classifier also we are using. It's fine, it's working fine. Now we will train the model using the training sets. That's what we are going to do. And we are training the model. Run it. It's working fine. After training, we will check the accuracy using the actual and predicted values. You know that. See, I am trying to print the accuracy of that model. Let's see how it. See, we got an accuracy of 0.9333. It's good. It's working fine. Now you can predict which type of flower it is. So you can see here. It's showing array 2. Array 2 means, it's 2 indicates the flower type Virginia. You know that. See, Virginia, right? Right. So again, we are, from SKlearn, we are importing a random classifier and create a random classifier for here. Run it. Now train the model using the training sets. See, that's what we are doing. We are going to train the model. So you got the classifier, right? So this is the output you are getting. So you have, all the class underscore weight none, category it's Genie, max underscore depth it is none, max underscore features auto. So you got that. Now we are importing pandas, and we got the petal length, petal width, sepal length, and sepal width. So we got it. Now we will do a visualization for these details by using the matplotlib. Let me show that. You can see it here. This is the petal length, petal width, all the features it's given, sepal length and sepal width. It's showing. It's a visualization using the matplotlib. Now see, you can remove the sepal width features because it has very low importance. Here you can see the sepal width, and selecting the 3 remaining features. That's also you can do by using the scikit learn. This is another thing, so I can show you that. Because the sepal width, it is not that much significant. That's what we are removing that. After that, you can again print the accuracy. We are again doing that. Yeah, we are getting it. Now we will do the prediction and we will try to do the accuracy. Now we got the accuracy as 0.9428 because previously it was 0.93. See, accuracy is increased because this thing we removed, the sepal width, it is, not that much significant. So that's all about the implementation of our random forest. So we have covered that as well. So thanks for watching. Please like, share and subscribe. Thanks a lot.